Hey folks, welcome back. My name is Bill and I'm a developer advocate here at Rerun. Welcome to part 3, a gentle introduction to Rerun. In part 1, we did some very basic static points. In part 2, we started talking about animating data with multiple frames. And now in part 3, we're going to explore this really powerful feature, the entity hierarchy and 3D transforms. By the end of this video, you're going to understand how to create parent-child relationships between entities and build much more complex animations using transform inheritance. More specifically, we're going to build a simple solar system with a sun, a planet orbiting, and 2 moons orbiting the sun, and 2 moons orbiting the planet. This will perfectly demonstrate how transforms cascade through the entity hierarchy, where each position is defined relative to its parent, or I guess the inverse, a parent to it from its child, making complex multi-body animations much simpler to manage. This comes up so much in the robotics domain, where maybe we have a robotics arm and we want to be able to really be able to specify, say the hand in relation to the elbow, as opposed to perfectly trying to manage everything in space. And so given that, I'm really excited to cover this topic with you because frankly, we're starting to see the power of Rerun. So enough yapping, let's get started. So here we are in part 3. I've already run the visualization. We'll sort of dive into it in a moment. I've got the code pulled up here on the right. Let's go ahead and get started. And for this particular step, I'm just in our standard code file that we've used, or code folder that we've used throughout this tutorial series. So let's go ahead and run part 3. Now, this one, I added some input values here because I want to talk about each of these things in discrete moments in time. The reason being is that how we set this up ends up being really informative for how you can apply this. So we're basically going to combine code review with actually producing our animation, and we'll understand a little bit more about time while we do that. So first things first, you can see here that Rerun is logging things over time. And even though this script hasn't finished executing, we are able to see things intermittently, right? So first things first, we can see here that we run our initialization. We then set up our view coordinates as well. Then we will create the sun right here. There's our sun. So we were just like inside of the sun, basically. So we create the sun. We will create the planet, which is inside the sun because it's smaller. So that's me just using the scroll wheel and command, or I guess I don't need command. I can just use the scroll wheel to zoom in. So we've basically broken through the surface of the sun to see the planet. And from here, as we proceed forward, we'll break through the surface of the planet. We can see our first moon and then our second moon, which I think is probably the same. Oh, yes, you can just see it very briefly right here. So that's us proceeding through this code as we create these things over time. So now we're at this first breakpoint, if you will. Let's go ahead and hit continue, and I will just zoom out here. Now what we have done is we have basically, I think I need to zoom out a little bit more. Yeah, so what we have done is we have created, there we go, some circles. These circles define the different paths of the moon or the moons and the planet. And you'll see here that basically everything is like stacked on one another right now, right? They're all really just logged or produced really at the origin. And that's going to come up here in this next sequence. So let's go ahead and run that. And now as we zoom out, great. So now we can see everything here. And what we'll be able to see, just make sure that I've got my full timeline here. Great. So I'm clicking manually through the timeline. Obviously, we can just go to the end there. I just hit the play button. Now we're at the end. You can see here we have the sun, we have the planet, we have each of the moons, and then we have those circles that represent how the rotation. You'll see one is an oval, one is a circle. Let's go ahead and actually go through how we define those. So obviously each of these objects needs radii, but the powerful here is this transform 3D archetype. And basically what we're saying is that one, this thing should rotate. Now these things are all the same color. So an exercise for you might be to change the color in order to observe that rotation. I just wanted to sort of have that notation to be able to show you. You can see here that we have the translation, which controls exactly how we're like moving the planet in space, and that we are transforming it. And I think that what's really important here is that implicitly we are defining a relationship from the planet to the sun. The same applies for the moon, except rather than the moon being related directly to the sun, it's now related directly to the planet. So this is where this entity hierarchy gets really, really powerful, right? And we've explicitly called out the relation here. This relation, I believe, yeah, there it is right here. I think the default is child from parent, so I didn't need to be explicit here, but doing that to show you that there are different ways of doing it. For instance, we could also do the inverse, right? And robotics has a ton of these kinds of problems, right? You might have an end effector, and maybe you want to define where the elbow is because of where that end effector is, right? A lot of these are just sort of like design decisions. More of what I wanted to really pull out and share with you is that there are different variations here that you're able to use. And then you can see we have the second moon that is also off of the planet. So I don't need to just have one sort of set of relationships. I can cascade this to even multiple objects. So you can see here, this is where we have our breakpoint. So I stopped it after this first frame to be able to show this entire setup, everything set up, and now we can continue. And what I am going to do here is I am going to actually change this to log tick. And the reason being is that if we just do it based on log time, right, basically when something is exactly logged, you can see that the difference between when we log it at first, right here, and then right there is far less than a second. So I guess maybe I could just play it and you'll actually see why I want to change it. Is that when this plays, it's going to go very, very quickly based on log time. However, if I do it based on log tick, then we're still covering 30 frames per second, but it treats it basically slows things down by doing it based on tick as opposed to when it happened in real time. So again, that's another example of the power of Rerun sort of time-based, how Rerun works with time. But you can see here that we have these particular rotations. It's moving through space. It's all very pretty. We've done all of this without ever really directly specifying where this object is in space. It's all defined by that entity path hierarchy and that entity hierarchy. We can see here, just like we've seen before, that we are logging all of these points. Now we could imagine that some of these points only show up at certain times, right? In sort of like real world robotics. I think another thing I wanted to call out is that we have defined these transform 3Ds. We have also, I guess, implicitly, more or less, defined these as the same object, right? So this is actually really important where we're logging that we have this points 3D component, right? But we're actually defining its location at a different log time. And so, I guess I've said it a couple of times at this point, but Rerun's notion of time is super, super powerful because we can log different things at different times. We can even log things in like in the past, or I guess in the future for that matter. And a lot of this just gives you as a programmer, as a robot, as someone building with robots, or doing manipulation in 3D space, whatever the case may be, just a ton of control and power to manipulate all of these things to get the right visualization and also build amazing things. And so with that, now you really understand 3D transforms. You've gotten a much better sense of how to manipulate objects over time, how to manipulate them in space, how to define relationships between them. And in the next couple of videos, I think this is really like the break point for, say, part 3 of this, 5, 6 part series, is that you really have the basics of Rerun here. You've learned about archetypes, you've learned about these 3D relationships, we've touched on time, and the next little bit is going to start using more real world data to be able to drill this home and show you even more powerful things given that real world data. And so thanks for sticking with me. I'm really excited to dive into some real world data in this next video, but with that, we'll leave it right there. Look forward to seeing you in the next one.